chemistry students. Today we're going to talk about the chemistry of solutions. And the first part of that is talking about electrolytes. You hear a lot about electrolytes, but do we ever really know what they are? Electrolytes are substances that dissolve in water, and they make a solution that can conduct an electrical current. So any soluble ionic compound is an electrolyte. Ionic is the key word, remembering that we have a metal and a non-metal, and they're charged, so that makes it an ionic compound. Some highly polar covalent molecules, such as strong acids, can also be electrolytes. So, some questions to ask if you are trying to decide if something is an electrolyte. Is the substance ionic? And remember, we have to go back to our periodic table to look at that. So let's take a look at CaCl, calcium chloride. So is calcium chloride ionic or is it covalent? Well, if you remember back to your periodic table, calcium is an alkaline earth metal and chlorine is a halogen, and both of them are charged. So yep, we got that part right. It is definitely an ionic compound. Then we want to know, is the substance soluble in water? Well, this is a little bit different because what we're asking is, does it really dissolve in water? We have to use our solubility rules. So our solubility table right here is a way to look, and this is on the back of your star chart. So what we mean by soluble means it can dissolve. So it can dissolve. And if you look over here on the other side, we have this portion that says exceptions. That means that it can't dissolve or it's insoluble. So it's not going to break apart. So let's look at calcium chloride to see if it's ionic. So we've already determined it was ionic, so let's see if it can dissolve. So we're looking at the ion, the negative ion, and there we see chlorine. It can dissolve. Are there any exceptions to chlorine dissolving? Well, if it was with silver, if it was with lead, or if it was with mercury, I believe that's what it says, it couldn't dissolve. So it's with calcium, so we know that yes, it can dissolve in water. So it is ionic and it can dissolve calcium chloride. Let's go to this one. This is a H2SO4. So H2SO4 is a what? It is an acid. So it is definitely has some ions. So it ionizes, dissociates in water. It's not covalently bonded. So we can take a look at that SO4, that sulfate. Is it in a soluble situation? Yep. It dissolves in water, except when it has a connection with these. So yeah, this one is also going to dissociate in water as well. The last one is NaOH. Is that an ionic compound? Yes, it is. Na is +1 and OH is a polyatomic ion. So we're going to look over here to see if OH, or hydroxide, is soluble in water. And we see down here that no, it is not. It is insoluble in water. So if it's insoluble in water, that means it is not going to break apart. It will not disassociate. But there are some exceptions. The exceptions are when it's mixed with a compound of ammonium, or if it is an alkali metal that it is associated with or bonded with. And Na, as we know, is an alkali metal. So this will also dissociate in water. And there we go. So dissociate in water. All right. So taking a look at our next, oh, and by the way, Gatorade. We always talk about Gatorade being an electrolyte. We want to have those electrolytes to use if we get dehydrated, and so Gatorade does have electrolytes in them. So we can take this a little step further. We can actually write reactions that show how the compound or the compound dissociates. So the first one we have to see is an electrolyte. Yes, calcium chloride is an electrolyte. And the second thing we have to do is see if it's dissolved in water. And on the prior page we said yes, it does dissociate in water. So let's go ahead and break that down. So this is how we write it. We write the compound, CaCl2, and we say that it yields, or we draw that little yields line. And we just basically break it up into the parts that it came from. So we know that calcium has a charge of 2, and chlorine has a charge of 1, -1, so +2, -1. But we have to make sure that we account for this 2 here. So we put this 2 as a coefficient, meaning we have 2 chlorines there to combine with that 1 calcium. All right, let's do the next one. H2SO4 is an electrolyte. Yep, we've already determined that. It broke up pretty well. This is an acid, but it is an electrolyte. So we can break it up. H2SO4 yields. We write the charges. So for hydrogen, it's +1, and there are 2 of them, so we want to write that coefficient there. And then we are going to write sulfate. What is the charge on sulfate? Remember, it is -2, and there's only one of those, so we've done it. So that's a dissociation reaction. Let's do the last one here, number 3, and I'm going to let you do number 4 and 5 by yourself. So sodium hydroxide is NaOH. Oh, and by the way, we did find out that it is ionic, yes, and it does solubilize, it does dissolve, and when hydroxide is combined with our alkali metal. So we're going to write this as 3 NaOH, and we write Na plus, which is the charge on sodium. We're going to write OH minus, which is the charge on hydroxide. And we have, let's not put the coefficient right there, okay? Because that's not in your notes anyway. All right, so that's how these break down, and those are dissociation reactions. Pretty cool. All right, we're going to go on to our next page, and this is about concentration and molarity. The measure of the amount of a solute in a given amount of solvent or solution is the concentration. So if you make Kool-Aid and it's concentrated, then you are talking about the amount of solute, the amount of Kool-Aid in the water. So molarity is an expression that we can use of concentration. In fact, it is a mathematical expression that we can use. So the formula for molarity, and notice this is big M, okay, big M. So it's a capital M there for molarity is equal to the amount of solute, which is in moles. Notice we can abbreviate it MOL. And that is divided by the volume of the solution, or the volume of the entire solution, which is liters, okay? And so if you're given a mass, you have to divide by the molar mass in order to find the number of moles of solute. And so you'll have to do some dimensional analysis to do that. Molarity is designated by the capital M, okay, directly after the number. So molar refers to molarity. So as you increase molarity, the solution is more concentrated. Low molarity means you have a dilute solution, and a higher molarity means you have a concentrated solution. So if you have a 5 molar solution versus a 0.5 molar solution, which one has the more concentration? It would be your 5 molar, because that would be a whole number. All right, so go ahead and fill in your blanks there. As you increase molarity, the solution is more concentrated. Low molarity means that you have a dilute solution, and a high molarity means you have a concentrated solution. So stop and fill in those blanks there. So the last thing we want to do on this video is work some of these molarity problems. So here we have our equation. The amount of solute in moles divided by the volume of the solution is going to equal the molarity. So what is the molarity of a solution that contains 1.54 moles of sodium chloride in a 3.5 liter solution? So we can write this, and this is on your star chart. You don't have to memorize this particular equation. It's easy to memorize, but you don't have to. So the number of moles that we're given is 1.54. The number of liters of solution is a 3.5 liter. So we're just going to divide 3.5 into 1.54, and we're going to come up with 0.44 moles per liter. So that was a pretty straightforward one, pretty easy. Number 2 says, how many moles of HCl or hydrochloric acid are required to prepare a 0.8 liter solution of a 0.5 molar hydrochloric acid solution? So we have here molarity, which is 0.5 moles. Molarity. Molar, we also can use molar, remember? And then we have an amount of that solution, and it's 0.8 liters. Well, so the first thing we have to do is rearrange that equation. And remember that our equation is moles per liter. And so what we can do is multiply both sides by liter, so that we can eliminate the liters there and have moles on the side by itself. So we're solving for moles now. We're going to multiply 0.8 times 0.5, and we will get, when we put it in the calculator, 0.4 moles of hydrochloric acid that we're going to need to make that solution up. So that was pretty simple. And so number 3 is a little more difficult, because we are going to have to, we're given grams. We're given 35.8 grams of lithium hydroxide. And so we're going to need to dissolve that into water, and we want to make 750 milliliters of solution. So what is the molar concentration? What's the molarity? We have to do a little backtracking. The first thing we have to do is convert 35.8 grams of lithium hydroxide, and we want to make that equal how many moles. We need to know how many moles it is. So we know that the molar mass of lithium hydroxide is 23.45 grams per mole. And then we come up with 1.44 moles of lithium hydroxide that we can use. The other issue we're going to have here is, what do we have to put this milliliters in? It's got to be in what? If you answered liters, you are right. So we're just going to take the 750 milliliters and we're going to divide by 1,000 milliliters. This is milliliters. And we're going to come up with 0.750 liters. Well, I think we're ready. We've got moles. We've got liters. So let's plug that in. 1.44 moles of lithium hydroxide, and we have a 0.750 liter solution of that. We're going to divide 0.750 into 1.44, and we will come up with a 2.0 molar solution. We're going to keep 2 sig figs here because that is what we started with. That's the least number of sig figs we started with. See right here, remember, when we don't have that decimal, we don't count the 0. The 0 is not significant. All right, well, so that is the chemistry of solutions, and I wish you luck, and I will see you next time. Bye.